One part of my research focus looks at exploring how students make sense of computer science concepts. I'm looking at information visualization and how people use visualizations to make sense of large spaces of data.
When I was in grad school, my research focus was part of math called graph theory. It's not probably the kinds of graphs you're thinking of. It's more about studying a sort of very generalized network model.
I teach two first-year art history courses, Art and Visual Cultures of the World 1 and 2.
Last fall I was teaching our Intro to Business Functions, which is kind of an overall survey of some accounting, a little bit of finance, a little bit of marketing, a little bit of HR.
So you have differential calculus in the first semester and integral calculus in the second semester. It's all about rates of change. That's it. That's the whole big headline is rates of change. And it seems very particular and very niche. And then very quickly you see how it just blossoms into this topic that is good for everything. Anything that you can describe with a mathematical model, this tells you how that thing is changing, either over time or with respect to some other input variable.
In first-year art history, students are exposed to the world through objects and artworks and ideas. Students really enjoy that experience. They really enjoy being able to learn about geography, the history, and always from an interdisciplinary perspective.
The first course I teach is Computational Thinking, which is CPSC 100, and it's a course for students who are not interested in specializing in computer science, but they're still interested in understanding how computer science impacts society.
Show the students how each of those key functional areas actually overlap. So how does accounting connect to marketing? And really it's in Management 100 where we show those students how those puzzle pieces actually fit to make strong businesses, strong organizations.
But I think something that is less understood are the implications of these models on both the physical environment and our social-emotional relationships. People like to think that algorithms can't be biased, but if you use biased data to train an algorithm, then the algorithm can be biased. An algorithm can be racist, it can be sexist, all depending on how it was created.
Students are engaging with intercultural understanding at all times and using artworks to understand one another. They emerge as global citizens, seeking to understand one another's innovations, creativities.
Right now I'm preparing a lecture for my commerce students on calculating surplus. It's an integral. It's not a way you would think to use an integral if you were brand new to integrals. It's a little bit funky and surprising. But it's nice to be able to make those connections to showcase that this very specific thing we're teaching you has all of these broad ways of modeling lots and lots of different things.
There's an area of my research that focuses on self-efficacy. And self-efficacy is basically the belief that you can accomplish a particular task. Building self-efficacy is actually important to succeeding in the world. So what I've done in my research is look at lightweight strategies that we can embed and integrate into our classes, or regardless of the challenge that they face in their jobs in the future, they know that they have the tools necessary to succeed.